is week 5, lesson 9. We are all present, and we're going to go over talking about the null hypothesis and the alternative hypothesis, and then we'll just jump into our quiz. So, I didn't have very many questions. I think that I have to reread this chapter again to get a better understanding of it, because the first time I went through it, I was just kind of like, okay, well, that's okay, yeah, okay, whatever. But I don't know, did anyone else feel like that, or did it all make sense to you?
Really wordy. Like,
yeah,
use so many words. Like, it just seems so overly complicated. I don't know. Like, couldn't there be a shorter way to say it? But I think, I don't know. I think it seemed okay. I wasn't quite sure how we could tell, like, if it was a one-tailed test or a two-tailed test.
Yeah, I was a little confused on that too.
So isn't that just depending on how it's written? So if it's like the equals sign with a cross through it, it's two-tailed. But if it's greater than or less than, then it's just one tail or the other.
I do have it written down like two-sided or one-sided, so that's the same thing as one-tailed or two-tailed.
Yeah.
Right.
Yeah.
Makes sense.
And it's also kind of interesting because if you look at like the greater than or less than and things like that, and the two-tailed, only the greater than includes the middle and the right. Versus like if you just had the less than, it only included the left tail. So I thought that was kind of interesting.
When you're using that guide, that's like, is that only for when you're trying to find the p-value in the application applet thing?
Yeah.
So that way you know what side to fill in once you get the z-score for the the alternative hypothesis, right?
Yeah.
Yeah.
Yep.
I think I get that.
Then we have to shade the middle and the right, and less than is just the left.
Uh-huh.
Okay.
Only if the z-score is negative, right?
Yeah, that's true. Depending on what your well.
Because if because video, they only filled them on the left side because the z-score was a negative.
Because it wasn't a negative?
It was. So he didn't fill in the middle.
The middle.
Okay.
In fact, he didn't fill in the middle when it was an equal. When it was a he didn't fill in the middle when the alternative hypothesis was different. Was the different one, not greater than or less than.
Right. Because it could be either one, so that would be the two tails.
Right.
Yeah. What else? I thought it was weird that we have to say error 1 for when the null hypothesis is right or whatever, but then when you do the alternative hypothesis, it's the same. So you have to say, oh, that's just error 1. What? Why do we even have to do that step?
Yeah.
But whatever.
So are you talking about the two types of error?
Yeah.
So in a way, they're still both wrong, right?
Yeah.
Yeah.
One's just so for example with the drugstore, the drug side effects, it was saying there are no side effects or there are side effects. And you can't, I think that it's just picking that because you want to pick the result that is less detrimental.
Mm-hmm.
What else? How about the little thing that says, if the P is low, reject the null? That was good. Good to
Yeah.
remember.
If the P is low or if it's just less than the, what do they call it? Significant.
Alpha.
Yeah.
That I don't know. Marlies, you know?
Well, the definition of p-value is the probability of obtaining a sample mean or test statistic at least as extreme as the one you calculated, assuming the null hypothesis is true. So I think that you would reject it if it was not greater if it's not greater than, right?
So just no matter the low value, then it's rejecting.
So in the example that we had, in the video, the p-value was 0.017, where the level of significance was 0.05. So the level of significance was greater than the p-value. So therefore, the null hypothesis was automatically rejected.
It was automatically what?
So if the p-value is less than the level of significance, you reject the null hypothesis.
Right. But if it's greater, then you always accept? Or just
No, if it's greater, then, sorry, is that what you're asking?
Yeah.
If it's
Yeah.
greater, then yeah, you just don't accept it. You don't accept it. You just don't reject the alternative.
So you don't accept or reject it.
You understand what I meant? You don't reject it. It's not that you accept it. You just don't reject.
Okay. It's
The
on the table. Okay. Okay.
Okay. All right. Any other things? Oh, one thing, note, like just going over, X bar is now used instead of just X for the formula. So, but then I thought I read something too that talked about not using the sample mean or something, but I don't know. I don't know what I'm really talking about. Now I can't remember what it was, but I thought there was something saying that like you can't ever use this sample for it, but I don't know. Anyway,
It's probably because the formula in the video it included the it showed the mean standard deviation symbols, but really it was just the original mean.
that it came with the mean of the observed values. Okay. Okay, should we go, let's go fly a kite. Let's go into the test.
To the quiz, is that what you said?
Yeah. Whoa, there's a lot of questions.
Oh man.
Okay, I'm gonna pull up the app. Okay, so which hypothesis involves equality? That's the null hypothesis. Right?
Right.
I'm still opening my quiz. Sorry.
Yeah.
Just let us know when you guys have it all pulled up.
Okay, I got it. Sorry about that.
Okay, so for number 3, I said that I think that it would be the null hypothesis, the one that involves equality.
Right.
Yeah.
We're probably not going to wait for Marlies because hers takes an hour to respond. Sorry, Marlies. All right. Remember, the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true? The null hypothesis? Or the p-value? No, that's because we're going to reject. So then we believe the alternative to be the true one.
If the p-value is smaller than A, this would be considered a rare event and null hypothesis would be rejected.
So the alternative then we would assume to be true.
Yes.
On what the p-value is, or it's just saying
No.
Just saying, like, when you're going to try to figure out the p-value, then which hypothesis are we assuming to be true?
okay.
And that's when we're using the alternative one, right?
Yeah. I think if the p-value is smaller. I'm getting it so mixed up already. Sorry, guys.
That's okay, me too. That's why we're having this meeting.
Yes, if the p-value is, you assume the alternative, I think. Sorry.
Okay. Suppose the null hypothesis is the equals one. Okay, great. Which of the following represents the alternative hypothesis for a two-tailed test? So C, but with the equal sign slashed through it.
Right.
I agree.
Okay. Which of the following represents the alternative hypothesis for a left-tailed test? So that would be the less than one. So A,
First one.
right?
Mm-hmm.
And then
Yes.
for 7 is the greater than, so that would be B, right?
Yeah.
Okay. Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance or alpha. Use this information. Which relationship would result in failing to reject the null hypothesis? So if the p-value was less, wait,
Higher.
what would you say?
Higher.
Higher than, greater than.
Right.
Yeah.
So A. Would result in rejecting the null hypothesis. Oh, failing to reject. Okay, this one's the less than.
Right.
Rejecting is the less than. B.
Yeah.
Okay. That's how I read the first one. But
Wait, so number
failing
8.
to reject.
Wait, what's the difference? Which relationship would result in rejecting the null hypothesis?
Remember, so like not accepting it
Wouldn't that be B?
if it's less than?
On number 9, are we talking about the same question?
Oh, well, no, number 9 is B.
Right.
Okay, so
But-
we're still on number 8?
No, we're on number 10 now.
Oh, geez.
So
What
for
did you guys get for number 8 then?
greater than,
P-value is greater than A, right?
yeah.
Okay.
Okay. Number 10. The insurance company is reviewing the current policy. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. So which of the following would be the appropriate alternative hypothesis? So the average claim amount is greater than $1,500
Yes.
is what I would say to put down.
I agree.
Okay, which would be the appropriate null hypothesis? And so that one is the average claim amount is equal to, right?
Yes.
1500. Okay. So the insurance company selected a sample of 40 claims. They calculate the sample mean to be 1650. We'll use this information. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
Is normal? Well, the sample size is above 40, so it would be.
Well, that's a funny thing because in the book I thought like the one where it had 140, it said like the sample size was kind of small. But I thought anything above 30 was a good sample size to make it
I'm
the distribution
Yeah.
sample.
in my notes from this week. It still states that either of the conditions are satisfied if a population is normally distributable size is greater than 30.
Okay, so it still says it?
It did this week,
I
yeah.
remember that.
Okay.
But
So-
hey, can you walk me through the last answer? I want to understand it better.
Which one, 11?
Yeah.
Okay, so the null hypothesis, that's when if everything is always equal to. The null hypothesis is when they always use the equal signs.
Or it'd be what's believed already or assumed is
Yeah.
already true. So in the question, they stated they believe that the average claim amount was 15,000, so equal to.
So
that would be the
the null hypothesis, the original one basically is not going to say, well, actually we think it's less than, greater than, or not equal to.
Okay.
They believe it to be equal to.
Okay, got it.
Thanks for that question. Number 12. So this is a good assumption since the sample size is large, we're saying. Because it's still over 30.
Right.
Oh, super great. What theorem or law justifies your answer to the previous question? I have to look that definition up every time because I get it wrong. I want to say the law of large numbers, but I have to go back to my notes from last week in order to see which one is the sample mean and which one is the other one. So I have to go back, unless anyone knows it right offhand.
law of large numbers has to do with accuracy, whereas the central limit theorem has to do with
Has to do with what?
population. Oh, hold on.
That would
Yeah.
be the central limit.
I gotta look at my.
Normal. Yes, so central limit theorem. As the population increases, the sample becomes normal. Is the central limit theorem.
What? Why? No. Yeah.
So the distribution of the sample mean is normal when X bar is normally distributed.
Bye.
Thanks to the central limit theorem, our sample size is large. States that as the sample size gets larger, the sample mean will get closer. So you think it's the central limit theorem then?
That makes sense to me.
Yeah.
Okay. Perfect. All right. Which of the following is the test statistic as defined in this lesson?
The z-score.
So let's see. 1, 2. It's not asking N or X for the above information. It's just asking what the statistic is in general. Is it the z-score?
Yeah.
what it said, I think, in the lesson.
Did you read that in the lesson somewhere?
In the assignment, it said it.
The
Okay.
video, right?
Okay, let's see. So that is Z. Defined in the lesson. All
Can you
right.
guys hear me?
Who? Yeah. Cheyenne?
Yeah? Okay.
Yeah, I did Z. I saved it. You said. The historical mean of sales receipts at grocery store is 150 with a standard deviation of 40. Store manager suspects that the average has decreased. She sets up a hypothesis test with the hypothesis that the null is equal to 150, but the alternative is greater than 150. She will use a level of significance of 0.05. She then takes a simple random sample of 36 receipts from her store and computes the X bar equaling 144. So now we have to do, what is the Z-score associated with this test? So we have to do the formula. We have to do the formula Z equals X bar minus mu over standard deviation with the square root of sample, right? That one. When do we use the alpha in that? Do we even use the alpha in that? Why did it give us the alpha?
No, because we have to compare the
Alpha
Z-
Yeah, the alpha is for comparing the p-value. You don't use it.
Okay.
So we'll probably use it in a later question. But for this
Okay,
one,
'cause
we're
we'll need it.
calculating Z-score.
Okay.
And this is over the square root of n, right? That's the one you said?
Right, which N was 36, right? Because that's the sample that they took,
Yes.
right?
Yes.
Sorry, I didn't have my calculator ready. Just be a minute.
So the
Written.
mean is 150.
Yeah. So I got negative 0.9.
That's what I got.
1 second.
Okay. Britt,
Negative 0.899, right? Is that what you got?
I just got negative 0.9.
Oh,
Me too.
how did I get negative 0.89? But that would be negative 0.9. So I don't know.
I did negative 6 divided by 6.666667.
Yeah.
Oh, I just rounded. I did negative 6 divided by 6.67.
So I got negative 0.9. Is that what you guys got?
Yeah.
But we don't have to put negative in our answer, do we? Just
Yeah, I think we do.
Well,
Because it's just asking for the Z-score in this one.
yeah. So just put that in.
Put negative 0.9. Round 3 decimals. Yep, it was not 3 decimals, so.
So the p-value associated with the z-score is the area.
So we have to pull up the applet for that, which I have that with a negative z-score of 0.9. And it's, so if it's a negative z-score, I'm filling everything to the right for the area.
Well, it depends on the question. Let me see.
What is the p-value associated with the z-score from the previous question? Just so it's just two-tailed on each side. So it'd just be 0.3681.
I thought it was on the left side.
Only?
because it says
Yeah.
less than.
Okay.
that she assumes that it's decreased.
Okay, so
Yeah.
0.1841.
That's what I got.
Would be the p-value.
So just
So then we would compare
0.184.
Yeah.
Yes. And then we would compare that to the 0.05.
Yes.
Which is greater than that.
So did everyone already put their p-value in?
Yes.
Yeah.
Okay.
So our p-value is greater than the alpha, right?
Mm-hmm.
What was the significance? 0.05. Yeah, okay.
Yeah.
So we would fail
So
to
you
reject.
reject when the p-value is greater.
You would fail to reject. You
Fail
would
to reject. Yeah.
Right.
Only if it's less than, and it's not. So we're
You-
failing to
right.
reject the null hypothesis.
Yeah, you don't reject it.
Right.
What is your conclusion for this problem? That we have sufficient evidence that the true population mean is 150? Sufficient evidence that the true population is less than
We have
150?
insufficient say, or maybe not. Hang on.
I think it's the third one. We have insufficient evidence that the true population mean is less than. So we can't accept that it's below 150. We don't have enough information yet to rule that out.
We can't accept. So we have insufficient evidence that the true population mean is less than 150. Because we don't have like all the numbers to add up, or what?
Mm-hmm. Because we didn't reject it yet, meaning
Right.
we don't know that it's not true, but we don't have enough information
To say it's
studies.
greater than.
right to say that it's completely wrong. So we don't have enough evidence. Yeah, that it's less.
But is that A or C?
That's C.
Yes.
Okay.
19. There are two types of errors that can be made when forming this hypothesis. Which one involves rejecting the null hypothesis when the null hypothesis is true? 1.
Yes.
Type 1. The researcher decided that instead of using a level of significance of 0.05, he will use 0.01. Which of the following will be true? So the probability of type 1 error will increase. The probability of type 2 error will increase. The probability that the null hypothesis is true will decrease. His experiment will be more significantly valid. So the probability that the null hypothesis is true will decrease. Or the probability of type 1 error will increase. I don't know for this one. I would guess A or C, but I don't.
The one that makes the most sense to me is A. Because it's still greater than, so it would, the probability of a type 1 error occurring would still be there. Whereas I don't see the other three being applicable to this.
Because type 1 was just made with only using 0.05.
Right.
And so it's saying that A, type 1 error will increase. The type error 1 will increase. A, we can go with A. I like Cheyenne said. So if alpha is 0.05, compute the probability of committing a type 1 error. round 2 decimals. So what formula do we use for that?
I don't know.
Yeah, I don't know.
Yeah, I'm gonna look in the lesson.
I'll be right back.
Okay. Oh, what was the question? Compute the probability of a type 1. Oh, so is that the one where you just do 0.05? So like 100 out of, is that what it's saying? So it's equal to like 1 out of 20?
Wait, you divide it by what?
So the probability of committing a type 1 error is low. The most common value is 0.05. This is equal to 1 out of 20. Is that what it's asking for? It wants us to say 1 out of 20 or something? Compute the probability of committing a type 1 error. I don't know if that's what it's asking or not. Which is still the same answer, 0.05, but I'm going to keep looking. Hold on.
There wasn't anything like that in our preparation homework that I remember.
There's got to be.
Would it just be 0.05? Probably not. Same round.
I think in section 4.4, under level of significance, comma, A,
Uh-huh.
the second paragraph, it talks about the level of significance A must be chosen prior to collecting the data that is our standard, et cetera, et cetera. If we wanted to reject the null hypothesis, we could compute the p-value and then unscrupulously choose the A level in every case of A that is larger than, is this the right thing that we're looking for?
Well, it wants us to compute it. It said compute the probability of committing a type 1 error with the A equals 0.05. So is there a type 1 error thing that we need to be doing it again?
Is there an equation for this, or is this just talking about the chart?
So it also says be sure to always conduct a test using p-values. In this course, we will never compute or use critical values as part of a hypothesis test. We will never compute or use critical values as part of a hypothesis test.
Speechless. I'm speechless.
I'm confused.
Isn't it just if it's 0.05, the computing the probability of committing a type 1 error is 1 out of 20. So do we just type in 0.05?
Why 20?
Because that's what 0.05 is. It's 1 out of 20. 1 out of 20, you're going to make that mistake. If you did 0.01 or whatever, it's like 1 out of 100, you're going to make that mistake. So this is just saying 1 out of 20, we're going to make a type error 1, so compute the probability. So is it just asking us to put 0.05? I don't know.
Yeah, there wasn't anything like that on our preparation.
So the only thing that I was looking at, what I'm talking about, was right here in the 4-5, type 1 and type 2 errors in lesson 9 in our reading.
Okay.
I just want to read on that. So the probability of committing a type 1 error is low. The most common value for the alpha is 0.05, which is equal to 1 in 20. So when the null hypothesis is true, there is a 1 in 20 chance that it will be rejected at the 0.05 level of significance. So so the probability of committing a type 1 error is low, so would it just be 0.05?
Yeah, I don't know how else to work it. I don't like a formula or
Okay.
different way to do that. So
Okay. Well, we can continue on later, but we did complete the test, and so I will stop the recording and then we can turn our stuff in, and if we still have questions, we can go over it.